Small LCD screens are a great, inexpensive way to display information in your electronics projects. In this video, I'm going to compare LCD1602 modules wired to Arduinos and ESP32s, and I'll show how I2C can simplify this process. First off, here we see a standard LCD1602 module, which is a liquid crystal display consisting of 2 rows of 16 characters, hence the name. It has an LED backlight. This module came as part of one of my Elegoo Mega starter kits. We can see it has a pin header here, already soldered in place, and this makes it very convenient for use with a breadboard. And it has a total of 16 pins. So let's have a quick look at what those pins do. So I'm not going to go into this now, but I'll include a link in the video description that has more information. Okay, so what is I2C? I2C stands for Inter-Integrated Circuit. It is a serial bus protocol that can usually support over 100 devices over short distances, where each device must have a unique address on the bus. I purchased some 1602s with attached I2C modules from Amazon. Here we can see a 1602 with an I2C module below a regular 1602. These components have a default address of hexadecimal 27. If you'd like to change the address for some reason, for example, if you'd like to support multiple LCD screens on a single bus, you can short the A0, A1, and A2 pads to change the address. If you're unsure of your device address, you can hook it up to the I2C bus on your Arduino or ESP32 and run an I2C scanner sketch. Here we can see an example of an I2C scanner for Arduino. I'll include a link to the sketch in the video description below. Next, let's have a look at the 1602 I2C module pins. The I2C module has only 4 pins. We have ground, VCC, SDA, and SCL. VCC supplies 5 volts to the module. The SDA and SCL pins are the serial data and serial clock pins, which are used to handle communication. Also, here on the back of the LCD screen, we can see that the I2C adapter features an onboard potentiometer, which can be used to adjust the screen contrast using a screwdriver. Here's a diagram showing the wiring of an Arduino Mega to a 1602 on a breadboard. Note that we have a 10K potentiometer to control the screen contrast. In total, we have 9 wires going over from the Mega to the breadboard. This is a lot of wires. It could have been 13 wires if we had used 8 data pins instead of 4. This feels kind of like wiring something in the 1970s. Here we have a Hello World sketch on GitHub. A link to this code is provided in the video description. I uploaded this sketch to the Mega. Let's look at the physical wiring. To keep things clean, I'm using ribbon cable from the Mega to the breadboard. On the breadboard, I've got the LCD plugged in, and I've also got a 10K potentiometer here on the end for contrast. Here we can see the Hello World sketch running. We can adjust the screen contrast with the potentiometer. Next, here's a diagram showing the wiring of a Mega to a 1602 using I2C. Notice how simple this wiring is compared to the previous example without I2C. The ribbon cable has gone from 9 wires to 4 wires, plus we've replaced the standalone potentiometer with the integrated one on the back of the LCD. Next, here's the physical wiring of an I2C 1602 to the Mega. We've got a ribbon cable with 4 wires from the Mega to the LCD. We've got ground, 5 volts, SDA, and SCL. I modified the Hello World example sketch to use an I2C LCD library and uploaded this sketch to the Mega. A link to this library on GitHub is shown in the video description, along with this example sketch. The ESP32 microcontroller is powerful, inexpensive, and widely used. So let's look at an equivalent setup for the ESP32. Note that it comes in a wide variety of development boards. Here I've got an ESP32 development board, and I'm going to plug it into a breakout board, which is somewhat similar to an Arduino Mega or Uno in that you can do things like plug in a barrel connector for power. In terms of wiring, we have the same 9 wires on a ribbon cable going over from the ESP32 to the breadboard. We've got 4 data wires, an RS wire, an E wire, a 5-volt wire, a 3.3-volt wire, and a ground wire. I've got the wires hooked up in a way that's convenient for the ribbon cable. Here we can see the Hello World sketch running on the ESP32 when we plug in power. A link to the ESP32 to 1602 sketch is included in the video description. Last of all, here's a diagram showing an I2C 1602 wired to an ESP32. Once again, we've simplified our circuit at a high level since we're just using 4 wires here. Here's an I2C 1602 wired to an ESP32. The breakout board obviously has been designed to take into account the I2C bus, since we've got the 4 required wires separated out into a specific unit on the breakout board. We have ground, VCC, D21, and D22 all together. D21 is the data wire, and D22 is the clock wire. Since LCD modules that support I2C are inexpensive, I choose them over modules without I2C for prototyping since they result in significantly simpler wiring, which typically means that there's less of a chance of things going wrong, like having a wire get disconnected. Links to the code examples and diagrams used in this video are provided in the description. In conclusion, I hope this tutorial has been informative. Take care.